Hello and welcome to the second lecture of section 6, Elastic Load Balancing, ELB. What is ELB? ELB stands for Elastic Load Balancing. In simple English, an ELB divides the amount of work that a single computer has to do among multiple computers. ELB automatically distributes incoming application traffic across multiple EC2 instances or servers. It can distribute your application traffic in a single app availability zone or across multiple availability zones. So what are the benefits of ELB? Highly available, can load balance across a region, routing traffic to healthy targets in different availability zones. Secure, ELB works with Amazon VPC to provide robust security features including integrated certificate management, user authentication, and SSL decryption. So it uploads the load from the server by going ahead with SSL on ELBs. Elastic. ELBs are elastic. This feature ensures rapid scale up or down ability based on traffic. Elastic load balancing is capable of handling quick changes in network traffic patterns. What are the benefits of ELB? Continuing from the last slide. So these are flexible as well. ELB allows you to host multiple applications on the same instance. It can use IP addresses to route requests to application targets. So earlier with the classic load balancer, multiple applications were not possible, but with application load balancer, multiple applications on the same instance are possible. That is, microservices architecture is supported. Robust monitoring and auditing. ELBs allow you to monitor your application's real-time performance with Amazon CloudWatch. Then hybrid load balancing. ELB offers ability to load balance across AWS and on-premises resources using the same load balancer. So on-premises supported as well. ELB types: application load balancer, network load balancer, and finally classic load balancer. Application load balancer. These are the most widely used, and load balancing of HTTP and HTTPS traffic is supported. It is best suited for modern application architectures, that is microservices and containers. So both are hot topics, microservices and containers, and both are supported on application load balancer. It operates at layer 7. So if you are interested in telecom domain, or if you are from electronics and telecommunication background, you will understand what is this layer 7. Otherwise you can just ignore it. Network load balancer, it's the latest addition among the ELBs. Load balancing of TCP traffic where extreme performance is required. Can handle millions of requests per second while maintaining ultra low latencies. It is optimized to handle sudden and volatile traffic patterns. So remember this, for sudden and volatile traffic patterns and for ultra low latency, you have to go for network load balancer. It operates at layer 4. Classic load balancer, its usage is on decline. It provides basic load balancing capabilities. To get a good understanding of our discussion till now, we'll go for a quick lab. We'll create an application load balancer. So these are the lab prerequisites. We'll require 2 running EC2 instances in the same region and install IIS in both the instances. For these 2 prerequisites, you need to refer EC2 Labs section 3. And then we will require static web pages deployed in each instance for testing the load balancer. So you can refer the same EC2 Labs section 3. Once you are ready with the above prerequisites, you can sign into the AWS console. I have logged into AWS console and we are inside Mumbai region. For a demo of load balancer, you must go to EC2. So I will click EC2 under compute and let us go to EC2 dashboard. And as already discussed with you in the theory part, we must have it's better to have 2 running instances for this demo. Even you can do it one instance as well, but to get the concept, to get the clarity, required clarity of a load balancer, you should have 2 running instances. So here I have already configured 2 instances for you, server 1 and server 2. Now to go for a load balancer, to create a load balancer, we will just scroll down a bit, and here it's load balancing, load balancers. So I will click load balancers over here, and now we are inside load balancer. Since we don't have any load balancer as of now, it's not showing anything over here. So we will create our first load balancer. I will click create load balancer. So here we have to select load balancer type. You have already seen the 3 kinds of load balancer: application, network and classic. We will go ahead with the most modern one and the prolific one, that is application load balancer. We'll click create. So now we have to configure the load balancer. This is step 1, and right now we are going ahead with basic configuration. So for the name, we can write it as demo ALB, that is demo application load balancer, and scheme is internet facing or internal. We will keep the default, that is internet facing, because we want to publicly access it. IP address type is IPv4. There's another one as well, IPv6. So we'll go ahead with the most popular one, that is IPv4. For the listener, we can keep it as default, that is HTTP, and load balancer port will be 80. So a listener is something which checks the connection request using the protocol and port that you configure. Okay, default is HTTP over port 80, and that what we have seen. If you want to go ahead with a secure listener, you can add HTTPS as well. So HTTPS will be on port 443, but for this demo we'll keep it simple and we'll go ahead with HTTP. For availability zone, in Mumbai region we have 2 availability zones, 1A and 1B. We will keep both of them. Okay, and for tags, let us name it something as application load balancer, and I will click configure security settings. Configure security settings. Step 2, improve your load balancer security. Your load balancer is not using any secure listeners, so it is prompting us to go back and create and add one secure listener, HTTPS. So you can ignore this for this demo, not a problem at all. This is not a production server. So I will click next, that is configure security groups. Okay, and here we can have a new security group, or we can select an existing security group. We'll create a new one. So let us see, LBSG, and keep the description as it is, no problem. And we will allow HTTP over port 80, that's fine, and source from anywhere to make it simple. Then we will go ahead with configure routing. So now we are in step 4, that is configure routing. Your load balancer routes requests to the targets in this target group using protocol and port that you specify, and performs health checks on targets using these health check settings. So here we need to provide a target group, okay, so that our load balancer knows where to look out for the resources. So we will go ahead with a new target group and name it as my target, or better my LB load balancer target, and protocol is HTTP port 80, and target type can be instance or IP. So we will go ahead with instance. Health checks should be on HTTP and on at default path. Leave it as it is. Advanced health checks also you can leave whatever is there as default. Now we'll go ahead with register targets. So now we have to register targets. Register targets with your target group. If you register a target in an enabled availability zone, the load balancer starts routing requests to the target. So you have already seen we have selected 2 availability zones. So inside 2 availability zones, it has found 2 servers, server 1 and server 2, that we have already seen in EC2 dashboard. So we'll select both of these to participate in our load balancer as a target, and now we will add this to our load balancer. Now these are added over here. So we have these 2 as registered. Okay, and now we'll go next step, next review. So here's a review of the load balancer which we are creating. Go ahead and click create. Close it. So we are here and the state is still provisioning. So I will pause the video for a while, maybe a couple of minutes, and I will resume after some time. I have resumed the video and now the state is active. So it took around 2 to 3 minutes from provisioning state to active state. Now let us see the description part of this load balancer. Once you select this demo ALB, the description will appear by default, and we have one DNS demo ALB and some alphanumeric number is there. We'll copy this. It is copied now, and let us check what happens. Okay, so welcome to the load balancer demo. This request is served by server 2. So this is our load balancer. Okay, DNS of our load balancer, and now it is serving request through the 2 targets, that is 2 servers. So this is coming from server 2. Whatever we have identified as server 2, this request is served through that. Now let us refresh this page. It is still server 2. Now it is served through server 1. So I will keep on refreshing and see what happens over here. 2, 1, 2, 1, 2. Okay, so I think you got the point. It is balancing load between the 2 servers. Okay, so a few requests will send to server 1, a few requests it will send to server 2. So I think this makes sense to you. Now we'll go and check what's happening in the instances. These are the 2 instances, that is server 1 and server 2, where we have which we have put as a target. Okay, so here you need to review the EC2 section. Okay, in EC2 section we have already described, we have already discussed in a few of the lectures how to configure IIS within this Windows instance, and how to go ahead with a default website, how to create a website after installing IIS. We will check this default website. We'll go to explore and see, this is the index page which is inside www and www is in inet pub. So this is the path, local disk C, inet pub, www, and here I have a simple page, simple HTML page. You can keep it everything, you can name it whatever you want, and you can put your HTML code over here. This request is served by server 2. So this is basically server 2, and we have another server as well. I'll just go to the other server. This is 177. I will go to the other server. So here we are in the other server. Okay, this is 140.ap, and we will check what's going on inside this. I have put inet mgr. Okay, and this is quite a replica of the previous one that you have seen. Here also you will find the same default website and the same set of settings, and now we can go and explore. Okay, index is here as well inside inetpub www root, and let us see what's there inside index. open with Notepad, and here it is. There in the previous server we have written it as server 2. Here we have written server 1, just to identify that the request is coming from this particular server. So hope this makes sense. And Elastic Load Balancer, I think you have found this quite interesting. And after this basic information and basic lab, you should go ahead and dig deeper into it. Now let us go back to our lecture, theory lecture. So here I am back to the theory lecture, and right now we will discuss the ELB along with EC2 instances, the architecture of the ELB which we had built just a while back in the lab section. So here's the architecture. I'll show you with a diagram. This is AWS cloud, and here's a particular region, and in this region we have got a VPC, that is virtual private cloud, inside this region. And then we have got two Amazon EC2 instances running in this VPC, and we have got one application load balancer inside that VPC. Then comes the users. We have 6 users right now, and they are trying to request to our application which is there in Amazon EC2, and those requests will be served through application load balancer. So application load balancer is right now getting, for example, 6 requests from 6 different users. Now it will go for a load balancing, and it will distribute 3 to the first instance and the other 3 to the second instance. So this is an overall picture of what we did in the last lab. So hope this was interesting, and with this we have come to an end of this lecture. See you in the next lecture. Thank you.